Hi everyone. I'm going to go over just a couple of the problems that we talked about during the tutorial and on section 7.1. So I want to first begin by just noting that some problems require you to find the next two terms, and some problems require you to find the 100th term, and some require you to find the nth term. And there's a difference. There's a difference in the complexity of the problems, and there's a difference in just sort of what you need to know at this time in your math journey. So I'm going to only assess on what is required per the book. I'm not going to add anything on. So for instance, if I ask you to find the next two terms, that's all I want. I don't want the nth term, I don't want the 100th term. We'll just go with what's required for right now. So the other thing is, I just wanted to let you know, so sequences can be arithmetic or geometric, or there's many others, and we aren't talking specifically about what kind of sequences these are. And when we do start to talk about that, which I think is going to happen in Math 11 or Math 12, then we'll get down to the real formulas for those. For instance, the recursive formula. Right now we're just talking explicitly about how to get the next term. So with that, I will go on to the first one, which I think the number is 1G, 7.11. So 7.1, and this is number 1G. And the pattern is 1 equals 1, 1 plus 3 equals 4, 1 plus 3 plus 5 equals 9, 1 plus 3 plus 5 plus 7 equals 16. And they're asking, what's 1 plus 3 plus 5 ... to 15? So if you look at these, let's take the difference in between each pattern. So this one, the difference is 3 between 1 and 4. Between 4 and 9, it's plus 5. Between 9 and 16, it's plus 7. And so you see that they're going up by increments of 2, starting with the odd number 3. The other thing I notice is this is 5 here, and that's 5 there. And this is 7, and that's 7. So if we want to get to 15, that means that we need to get to where it comes to be plus 15. But we're missing, this is 7, so we need plus 9, plus 11, and plus 13. So we know in the sequence order, then this is number 1, this is number 2, this is number 3, 4, and then to get to this term number, then our sequence number, we have this one is number 5, and number 6, and number 7. So this one is number 8. Just if you're thinking about where the equation falls in the order of things. So what I would do is I would just crunch the numbers. So 16 plus 9 equals 25. 25 plus 11 equals 36. 36 plus 13 equals 49. And 49 plus 15 equals 64. And so 64 is your answer. Okay, I want to do 2 more. So the next one is predict the next 2 terms. And this is when we went over in class, and we were able to get the next 2 terms, and then it was suggested, why don't I find the nth term or the 100th term? And that was a bit trickier because I hadn't already thought about how to do that. So I want to go back now, and we'll go back and review getting the next 2 terms, and then I will show you how to get to the nth term, or the nth term. So if we have these values, I'm going to put them into a table. So 1, term 1, this is t, term 1, 2, 3, 4, 5. And then I'll go down to 6 and 7 because that's there in the problem. Okay, and then here the terms are 1, 2, 5, 14, 41. And what's the next one? So let's look at the difference of the terms. So the difference between 1 and 2 is plus 1. You've added 1. The difference between 2 and 5 is you've added 3. 5 to 14 is you've added 9. 14 to 41 is you've added 27. And you see these are all multiples of 3. So this is, you could call this 3 to the 0. This equals 3 to the 1 equals 3 squared. 27 equals 3 cubed, right? So if we want to get to 6, the 6th term, then we take our multiple of 3 and increase it by 1. So it would be 3 to the 4th. And 3 to the 4th is 81. And we add 81 to the previous term, 41. So you get 122. So those two you add together to get this. Just like you added together the 2 plus the 1 to get the 3, and the 2 plus the 3 to get the 5 plus the 9 to get the 14. 14 and 27 gives you 41. So 41 and 81 gives you 122. And what's the next difference then between the terms? Well, that would be 3 to the 5th. And then 3 to the 5th equals 243. And 243 plus 122 is 365. Now I'm going to talk a little bit about how to figure out the value to, say, n, or even 100, or whatever you like. So let's go back here. So and look at, remember how I just talked about 2 plus 3 gives you 5, and 5 plus 9 gives you 14. So that's showing you something about the pattern. It's saying, okay, so this is the difference, plus 3 is the difference, or actually these are the difference. 3 to the 1st is the difference between 2 and 5. So if you I'm going to write it out. 1 plus, so if you take 1 plus 3 to the 0, that equals 2. Two plus 3 to the 1st equals 5. 5 plus 3 to the 2nd equals 14. 14 plus 3 to the 3rd equals 41. And so you see, this is our pattern. This number is growing each time by 1, the exponent. So the exponent is growing each time by 1. And this number is just the previous term. So the previous term plus 3 to the growing exponent gives you the next number. So I would say the n, the number n, so if we continue this pattern, equals the previous term, so the term n minus 1 plus 3 to the n minus 1. Okay? So it's kind of an odd looking thing, but it works. So suppose we wanted to find the 10th term. Well, the 10th term equals the value of the 9th term plus 3 to the 9th. And I don't know the value of the 9th term. I don't know the value of the n minus 1 term, but I know that this is the number I need to get, this value. So these are all the values in here. Okay, the last one we're going to work on is 2i. There may have been other questions, but I'm happy to answer those when you come back, or if you want to call me, or not call me, but email me with your questions. That'd be fine. So this one, you have 3, 5, 11, 29, 83, and then 2 more numbers. And so the question just asks you to find the next 2 numbers. It doesn't ask you to find the nth number. You certainly could work on a formula for that, but it asks you to find just the next 2. So we're going to say this is the term, and I like to use the v for value, but so let's go here. 1, 2, 3, 4, 5, and we need to find 6 and 7. Okay. So the first thing, is we go through and decide what the difference is between the 2 values. So in this case, it's plus 2, and this is plus 6, and plus 18, and plus 54. And so I know from these that there's some component, some 3 in here that goes on and on and on. So for instance, 6 is 2 times 3, 18 is 6 times 3, 54 is 18 times 3. So 3 keeps being multiplied to get the next number. So 6 is 2 times 3. 18 is 2 times 3 times 3. And 54 is 2 times 3 times 3 times 3. So this equals 2 times 3 to the first. It's 2 times 3 squared equals 2 times 3 cubed. So what do you think the next one is? Well, the next one is 2 times 3 to the 4th, and that is added to this number here, 83. 2 times 3 to the 4th is 162. So 162 plus 83 is 245. And the next number is, well, let's see, this is 162 equals that, and then the next number is 486 equals 2 times 3 to the 5th. So that's plus 486, and that gives you 731. So you know your next 2 numbers. So this is 731. Sorry, I'm having a little mouse trouble here. 245. So if we wanted to go on, suppose we want to do the 8th one. Well, if we continue this pattern, the 8th one, well, that equals the value of the 7th one. That equals this part right here. So this is t sub m minus 1, which equals the value of the 7th one, plus 2 times 3. Well, what would the exponent be? The exponent is, see, in this case it's 3 to the 5th, but you're working on the 7th term. And here it's 3 to the 4th, but you're working on the 6th term. So this would be 3 to the n minus 2, because we're on the Oh, 8 to the 6th, sorry, pardon me. So we're working on the 8th term, so we want 3 to the 6th, which is 2 less than 8. So if you did the nth term equals t to the n minus 1 plus 2 times 3 to the n minus 2. Okay, great. Thank you very much.